Hey, hello everyone. My name is Peter Zaitsev, and I am founder and until recently CEO of Percona, the company which helps people to be successful with open source databases. I come from engineering background, and frankly, I always was interested in database performance in particular. And if you are interested in database performance, you of course have to be interested in the CPUs because that is one of the big factors which influence the database performance, right? And that is what we are going to talk today about. We focus on Intel, AMD, and ARM because these are obviously their choices we have on the market right now. But let's start way back. One thing you probably know about databases is what databases always live the big iron, right? Like a lot of servers, mainframes were really developed so we could run the databases on them and then access that through, pretty dumb and simple terminals. What are we talking about the big iron in this case, right? Well, that means servers which have fast CPUs and many CPUs for its days, lots of memory, lots of storage, fast networking, and often very extensive reliability, right? For example, you would find many database servers of a day where you can hot swap CPUs, memory chips, and I'm not even speaking about the hot swappable storage. If you look at the early days, as if a lot of hardware, it was custom, right? Every manufacturer in the early days would have their own custom-made CPUs. Then standardization started to happen, right? And if you think about before the Intel era, if you like, we had a lot of servers running on MIPS, PA-RISC, Spark, and also a bunch of custom CPUs for big vendors like IBM used to have very special and complicated processing units for its servers. Now, if you what happened next is what PCs came to the market. And obviously, PCs first was thought as a low-cost desktop platform, right? And this is where what many of you may not remember, but in the early days, we had actually variety of those Intel compatible CPUs, right? It was not only Intel and AMD, but there is a whole bunch of different vendors like Sarik shown here was doing their Intel compatible CPUs. Those CPUs started from 8-bit, then to 16-bit, and then to 32-bit. At that time, when we could have a 32-bit computing, those systems became good enough to run kind of smallish databases. Maybe not your database for a big bank, but maybe databases which can power the small business, right? And that is where DB2, SQL Server, Oracle, they're all ported to those Intel architecture. It also was empowered by OS2 and Windows NT operating systems, which were more reliable and provided the multitasking, the good multitasking, right, which is required for multi-user databases, right? It would be pretty hard to write the good databases for DOS operating system or something like that. What happened next, I think, is this very interesting or classical, I would say, study of innovator's dilemma, right? Where we have this almost toy technology for very small databases really growing to then pretty much dominate their industry. One thing which helped, I think, here is this kind of too ambitious and I would say excessive innovation by Intel with Itanium CPUs in 2001. Unlike their progress of 8-bit to 16-bit to 32-bit, which all was building the compatible CPU generations, they decided to get some clean design and build a completely new architecture new concepts, new compilers, right, and everything. And that end up in this Intel Titanium processors, which were way too expensive and complicated for the mass market. Instead, we could see the leadership in the server space was taken by IBM, which introduced x86-64 architecture and Opteron CPUs. Right. I remember I was already involved in a database space at that time, and we used to love this technology, right? Because it was so much better for databases when you wouldn't have to deal with the limitations that architecture places on you, right? Well, even though this innovation was championed by AMD, Intel didn't just sit out there and let AMD to eat their pie, and they also embraced the same architecture. They just renamed that to EMT64 at that point and released 64-bit capable Xeon processor, right? And joined that 64-bit Intel CPU's rate at that time. What is interesting, though, is that was a time then there was a first success for AMD, right? You can see that kind of spike of their share of the market, right? In that time, that was because Opteron CPUs were quite good, and then for many years, Intel caught up and really almost wiped out AMD from a server CPU market until the recent successes with the EPIC architecture, right, happening in the next year. You can see that as a next growth. Okay, what happened next, or what happened also about that time? Well, you guys probably heard or lived through the dot-com crash in early 2000. But what you may not know is what before that time, we had been using a lot of expensive technologies to build internet. There was a lot of so-called Web 1.0 technologies built on Solaris, Spark, Oracle databases, kind of very expensive one. After that crash happened, well, guess what? The industry needed much cheaper choices. That is how open source, Linux, MySQL, Postgres, right, and many other open source technologies came out, right? We just needed to build the massive applications, like Facebook, but to do it on cheap. Now, what did that mean for the databases? Well, we really needed to do like a web scale database deployments. And what you can think about those databases, there is no mainframe large enough to be able to run such a database, right? You can't run Facebook on a single server, period. So the focus was on scale out, not just scale up. And as we started to get used to the scale-out technologies such as sharding in databases, we started to seek the optimal price performance, not just performance, right? Which I think is very important. Now let's talk about the ARM. The ARM was out there for many years, many decades, right? And this is technology which was first focused on custom chips with licensing the ARM architecture for low power devices, right? And they would provide the best performance for power budget. This is why, for example, so many mobile phones, right, and other personal devices would use the ARM CPUs. For years, they were kind of living in a separate space compared to their, I would say, the mainstream open source market. The first foray to the mainstream, I think, comes with a technology as a Raspberry Pi, right, which really showed a lot that, hey, what on ARM you can actually build quite capable, right? The small scale and power efficient servers, right? And that is where a lot of software has been supporting ARM in the mainstream, right? To run on Raspberry Pi and some other similar devices, we will see a lot of Linux distributions starting to support ARM. The other area where we see ARM being very successful is in the cloud, right? You can see AWS have been introducing a number of ARM instances, right, including like Graviton 3, like a third generation, rather recently. But really, they are available on the cloud vendors worldwide, right? But if you think about the market of the servers you can buy for your kind of conventional data centers, well, it didn't really pick up in the same way. Though, frankly, the market of data centers to be run by companies themselves have been shrinking too, right? If so much of the workloads moving to the cloud. The last important step, what to mention in the ARM space, is what ARM came to desktop and for real, right? Apple has decided to change the CPUs once again, right? And instead of using Intel for its laptops, it's designed its own ARM-based CPU, which was actually quite good. Typical problem with ARM was what ARM was very CPU power efficient. It also could support many threads, right? Many CPU cores, right? So it would have a good multi-thread performance, but a single thread was a lot slower compared to Intel CPUs, and that was a problem for many applications. What you could see in Mac's M1 CPU, it was actually pretty good, right? It was actually better than the previous generation Intel-based Mac Mini, right? And I think that is a very the important step which brought their ARM CPUs in what I would think their performance mainstream for a lot of developers, not just in the cloud where you would maybe ship for ARM, but you'll still have to develop for Intel. Okay. Now, let's talk about databases specifically. What do we see driving database performance? Well, there are a few things. It's, of course, CPU, but also compiler's ability to optimize code and software optimization for the CPU architecture. For example, a lot of software, a database in particular, were initially written with a lot of low-level optimizations to how x86 memory architecture behaves, right? And directly translated to ARM, that didn't work very well. It required some code changes. Next, I want to highlight about how we evaluate database performance. That is where we often talk about performance, price performance, or even power performance, right? Which are all important in the different circumstances. I think when you are thinking about looking at the benchmarks, it is very important to pick the workloads which are relevant for you, right? Because there is no technology which is best for everything. Typically, there are a lot of trade-offs, and when you evaluating those, you need to make sure workload is relevant for your case. You are specifically thinking about disk-bound versus CPU-bound workloads, as well as think about concurrency. Again, as there is a lot of trade-offs between a single thread performance and multiple thread performance. Okay. Now let's look at a couple of databases to see what happens. This is their MySQL performance on low VMs in Amazon cloud on the CPUs, right? And we can see in this case is what a Graviton, and this is a second generation of Graviton, right? Not the third, is actually doing quite good, which also happens with mid-range the CPU VMs. And only if you really go for the compute optimized instances, right, with the most powerful Intel CPUs, that is where we can get the Intel to very much match the Graviton CPUs, right? I think that is quite important. The second thing to highlight here is what their generations matter, right? We can see in this case a performance between the different generations of CPUs of the M5 and M6 in the AMD, and we can see what AMD in this case erases, or sometimes even leads compared to Intel, right? That is not a surprise, right? And I would just mind those numbers when you are choosing the instance types, right? Because often making sure if a new instance types are available, they can offer you much better CPUs. Second thing I think is interesting to highlight here is the costs, right? Often you're not just looking for performance which would want to be fastest, but you need to have an instance to handle certain workload type, and this is there you would often find what their Graviton-based systems are cheapest, right? And of course, that's the case, right? I mean, that is something which solution which keeps most money in Amazon, right? So there is no surprise. Okay. The second technology we want to cover in this case is a ClickHouse, and why that is an interesting as alternative, because it's very different from MySQL. It's an analytical database which has a lot of parallel query execution. It relies on a lot of special CPU functions such as vectorized executions, and also needs a memory bandwidth. Right? Let's look at SSB benchmark here. And SSB mentions or measures time in seconds, so lower is better in this case. And we can see what Graviton, G2, right, second generation, is actually doing quite good. And if you look at the Graviton 3 results, then we can see it has lowest query execution time, and that means highest performance in majority of use cases, right? So if your software can handle it, then give ARM a chance, you may be happy with results. Finally, let's look at the costs here. And I think what is interesting in this exercise is what we can see what their Graviton, especially their newest Graviton instances, are the cheapest for performance, right? At least for this particular benchmark, right? Which I think is important in your choices. Well, finally, let's cover briefly about what is a future looks like. Well, CPUs is where a lot of innovation happens. Even though I think the Moore's law kind of moved to GPUs those days, we are not getting CPUs which are, twice the performance every couple of years, but CPUs are still getting faster and faster, right? And we expect that to handle for all CPU vendors. They must innovate or die. We're going to continue to focus on the power efficiency, right? Because that is a limiting factor for CPU performance, right? We just need to be able to cool that thing, right? And that means we have to limit power, as well as there is a lot of a push for the greener computing, right? And I also expect cloud vendors to prioritize ARM because the ARM CPUs are cheaper, especially if you can develop your own CPU designs, as a number of cloud vendors, like and especially Amazon's, have been doing. With that, it's all I had to say, and that's been my pleasure speaking to you folks.